The next type of story problem that we want to solve is what we call a mixture problem. And the idea behind a mixture problem is that we've got some quantity being stored somewhere of item A, and we've got another quantity of item B that are related to each other. So we could be talking about amounts of mixing coffee types, or we could be mixing nuts and chocolate to make a trail mix, or we could be mixing gasolines to get a different ethanol level or oxygen level or whatever it is that we're looking for. Or we could be mixing interest rates so that we get exactly the amount of money every year that we want. And we're going to take these two and we're going to form a new item, our mix C, by taking some from A and some from B and mixing them together. And so that's visually what we're looking at. And conceptually, what we want to do, so I'm going to give you the model now, and then we'll work through a problem and see how it works in relation to the model. So it helps to have a table that's going to have 3 rows and 3 columns. So here's item A, here's item B, and here's the mix C. And then what we have is we have an amount of some sort. This is how much we're taking from each. So this is pounds if we're talking about coffee or trail mix or oatmeal or whatever type of physical thing we're talking about. This is the principal if we're talking interest. This is the liters if we're talking gasoline or acid. We have a rate, which is a percentage for some types of things, or it's a price per pound for others. What it does is it lets us convert this amount to something that we call the value. How much is this worth to us? And so this is the price, this is the interest, and this is how many liters are the thing that we're interested in. Whether that's gasoline, whether that's ethanol, whether that's acid, how much of what's in the bottle is actually that liquid, rather than the water that it's generally mixed with. And the other interesting thing about this is remember that our rate converts an amount to a value. And so if we have a rate R and we have some amount A, then the value is A times R. Or we could have B, T, oops, let's change colors so it stands out, and we get B times T. Or we could have our mix C times some rate U and get the value C times U. So we're always multiplying the first two and setting it equal to the third. Amount times rate gives value. Along with this, we want to recognize that the amounts and the values have to add up. So A plus B will always equal C, and this means that our amounts add. So if we want to mix 10 pounds of M&Ms with 20 pounds of peanuts to create a very simple trail mix, 10 pounds plus 20 pounds equals 30 pounds, and we'll have a mixture of 30 pounds. Likewise, we don't want to lose any value when we're doing this. This is the point in mixture problems. We don't want to sell it for less than it's worth, and we want to be able to get some specific amount out of it. So by the same token, A times R, how much we pay for those peanuts, or those M&Ms, plus how much we'd pay for the peanuts has to be equal to the amount we'd mix times whatever our new rate is. And that's, if it doesn't, then we're losing money or we're cheating somebody out of money, which is not something we want to do. We may, if we're a business, we may mark this up later, but when we're calculating this out, we want it to be even. And so we'd be marking it up so that we could charge it for more to take into account the fact that we created it ourselves. But this is our value equation. And this value equation is where most of the work that we want to do gets done.